Alrighty, let's take a look at what if we actually had to calculate. And so in the first video, we kind of looked at this rough run through. But what if I just gave you a polynomial or a rational polynomial and said, okay, find your asymptotes. So what I've done here is I've split it into three different categories, three different groups here. And so the first situation is specific, and the second specific, and the third is specific. Each one of these will have a vertical asymptote. So every time you still want to think about what your vertical asymptote is, and then also check for your horizontal or oblique. But remember, we're not doing oblique. I just have that on my notes. And so that way too, for future classes, if you ever have to find an asymptote, you're like, oh yeah, there is oblique. Okay, so in our first situation here, let's get a color that stands out. We can see here when we start this guy, we can see that on top, this would be x to the first over x to the second. And so in that case, we take a look at our standards here, and this means that we would have, that's x to the n over x to the m. So we can clearly see in this case here that our n is less than our m. So then we would use rule number 1. And in that case there, for rule number 1, for a horizontal asymptote, our asymptote is just y equals 0. So for this guy right here, our HA is y equals 0. So now we need to find our VA, our vertical asymptote. Well, our vertical asymptote is found from our denominator. So we first of all take a look and factor our numerator and denominator. So for our vertical asymptote, we take and we factor. So we have this function f of x is equal to x plus 1 over x squared minus 1. All right, so depending on where your factoring skills are, at this point we should feel more comfortable with the fact that this can be rewritten as x plus 1 over x plus 1 times x minus 1. And so in that case right there, what happens is that we say to ourselves, okay, well, we've got this guy factored. We see clearly that we have an x plus 1 and x plus 1 on the bottom, on top and on the bottom, so we cross those guys off. And what we're really left here now is 1 over x plus 1. Well, in that case, that guides us to where our vertical asymptote is, because at this point, we cancel our common factors, and we identify the values that make the denominator equal 0. So to actually find my vertical asymptote, I take my denominator and I set it equal to 0. I solve it for x, and I say that x is equal to -1. And so that right there is my vertical asymptote. That is the place where my graph would be undefined. That is an x value that if I plugged into this function, it would make this function undefined in the denominator. In the numerator, it would make it 0. But we don't really care about that. What we care about is the fact is that if we plugged it in the bottom, we would get 1 minus 1, which would be 0. Now, some of you might be saying, well, wait a second. If I plug it back into the original, it's going to make the original, the top and the bottom, no matter if it's 1 or positive 1, isn't going to work. But what you have to remember is that to be able to establish these vertical asymptotes, we have to take and simplify our rational function. We have to get rid of that common factor. And that common factor is what guides us and allows us to kind of see like what's going on there. Okay, so one last thing is, notice that no matter whether I took from the original or whether I took it from the simplified version, my degree on top is 1 degree less than my degree on the bottom, or is less than my degree on the bottom. So therefore my horizontal asymptote is still at y equals 0. Okay, take a look at the next one. See if I got my pen back. All right, sorry about that. So on the next one, we start off and try to clean this up a little bit. Let's simplify first. So let's take the guy and simplify. So let's try to do our vertical asymptote first. That's probably a better habit. So let's see. We have x squared plus 1 over 3x squared plus 1. Now, most common thing I think people would do here is be like, oh, I've got a 1 on the bottom and 1 on the top. I can cancel those. I have an x squared on top, an x squared on the bottom. I can cancel those. No, you can't. Okay, you cannot cancel things when they have an addition sign in between them, unless this is not what this is. I'm just going to rewrite this so that you can see this, and I'm going to erase it immediately after. The difference would be is it look like that. Because in that case there, this and this are a common factor. And I can cancel a common factor. But that's not what we have. We don't have that. We have a scenario where on the bottom, I have 3 times x plus 1. So that 3x squared is completely different than the plain x squared. So this cannot be simplified. So when I look at this, I take my denominator, so I take my 3x squared plus 1, I set it equal to 0, and I start solving it. So minus 1, minus 1, so 3x squared equals negative 1, divide by 3, and so I get x squared is equal to negative 1/3. Okay, we have our square root method, so we square root, we get x is equal to a positive or negative square root of negative 1/3. Now, right now there should be like red flags flying, and that red flag should be flying because of that negative sign right there. That means that when I simplify this radical, because of the fact that I started off with a plus sign right here in the denominator, when I simplify this, I'm going to end up getting plus or minus I square roots of 1/3, because that negative comes out as an I. That means that this is not real. This is an imaginary, this is an imaginary number, or a non-real solution. We're not looking for non-real solutions, we're looking for real solutions. So in this case here, when we come back to our vertical asymptote, we say none, because we don't have a real place that it crosses. It's a little bit abstract, but we can work with it. Now we go to our horizontal. On our horizontal, we see that our degree on top is a 2, our degree on the bottom is 2. That means that our n is equal to our m. And if our n is equal to our m, remember that we take our leading coefficient, so we take our numbers that are out in front. Well, it's understood that there is a 1 right there. That means that in this case here, my horizontal asymptote would be at y equals 1/3. All right. The last example would be an example where I had an oblique, so we don't need to do that one. We'll just cut that short. So vertical asymptote, horizontal asymptote, take a look at this, and then I'm going to make a video for a special situation of just kind of things we come across, but this will get you through the main concept.